Hey, hello, good evening, good afternoon. Jimmy Ballari, Pratiksha Darvada, Dhawan, Vaibhav Chiru. How are you all? How are you all? Am I audible, right, guys? Am I audible?
Yes, sir.
Yes, thank you. And then, how is your preparations are going on for the examination? Fuck. Okay, guys, within 1 minute, we'll start our session. Okay. And meanwhile, if you have any doubt regarding about the previous class means, do text me in a chat box regarding about oscillations. Because yesterday only we finished oscillation, which is almost all I completed maximum portion, which will be asked. Maybe question will be arises from your board exam and as well as the NEET and JEE. Okay, and you need to concentrate more on that spring body system. No, there is a series combination and as well as parallel combination. Okay, based on that question will be appear. Try to concentrate over. Okay, it will give complete idea about the problem solving. Cool. Is fine. Yes, okay, guys. We'll start our today's session. And then, as usually, this is Sham. I'm working as a program associate at JNE Haveri. As a being a physics teacher, I'm working here. And moreover, here I can see around five schools are there. Jain Churu. Jain Churu is there? No. It is belongs to which state? I don't know. And one more account is the student. And then Pratiksha Dawale and Vaibhav Kote. Can you guys introduce yourself from which school you people are? I know here only Ballari. I know. Feel free to drop a message. No worries. Okay. And one more point. I don't know why this will be happen. When I'm opening this chat box now, it will be visible to you people also. Okay, I tried it to sort out this one, but I can't able to resolve this completely. Okay, no worries. It's a completely transparent now. Nothing is personal. Okay, no problem. From Rajasthan. Great, bro. Great. Okay, guys. Today we'll start our session. In this session, we are going to mainly focusing on these topics. First one is waves kya hota hai, and then we are going to classify the waves and what will be the characteristics of wave and relation between path difference and as well as phase difference and characteristics of progressive wave and equation for the progressive wave based on this one good numericals too. Okay, these are the things which I bring today. I hope, don't know how much I will complete. Maximum I will complete this all the topic because this all the topics are very important for your examination also. Clear enough? Okay, let's start our session. Yes, why? Yes, before starting the session, we'll go through the quick recall what we discussed yesterday. Correct now? Yesterday we discussed about the energy and also energy based में वह एक ग्राफ भी बनाए थे हम. Correct ना? In this graph, actually, when simple pendulum or any system which making simple harmonic motion, उसके अंदर two energies होता है. First one will be kinetic energy, second one will be potential energy. Kinetic energy के लिए equation क्या बनता है? Half k a square, sorry k a omega square cos square omega t. Potential energy के लिए हाफ के ये ओमेगा स्क्वायर साइन स्क्वायर ओमेगा टी था. Correct now. Based on these two function, we draw one graph here, right? When the bob will be go extreme position, at this position, potential energy is maximum, kinetic energy is zero. When it is comes to this side also, at extreme position, potential energy is maximum, kinetic energy will be zero, because at this point velocity will become zero, no? And meanwhile, in a mean point, kinetic energy is maximum. Okay, na? Right? Based on this one, we draw a graph. At when it is zero, means y value will be zero. Kinetic energy is maximum. This is the position. And when it is moving towards the extreme position, kinetic energy gradually decreases over like this. And when it is comes to left hand side, that time also kinetic energy decreases. This is for the kinetic energy graph. Correct now. And then next point क्या था? Potential energy. At mean position potential energy value क्या होता है इधर? Zero होता है. That's why it is zero. As it is moving towards the extreme position, potential energy increases. Again in the opposite direction it is moving, means again potential energy is increasing. Right? These two things which we discussed. And moreover, the potential energy of the system will be equal to total energy. Right? This is also we discussed. If the total energy is maximum at the point, potential energy is also maximum. If total energy is minimum, where at potential energy is minimum. Clear enough? These are the topics we discussed. Based on this topic, guys, I have one small question here. I have only one small question. What is that question? देखो इधर. Question A है. When this will be oscillate, okay, when this bob which is moving towards the extreme point, its potential energy increases, kinetic energy क्या हो रहा है? Decrease हो रहा है. My question is, where the kinetic energy will be equal to potential energy? At what position? At what position? Can you guys answer to this question? Easy question है. देखो भाई एक साथ चेक करो एक बार. What is the answer? Check me. Check it once. पोजीशन पूछ रहा है. पोजीशन मीन्स क्या होता है? पोजीशन मीन्स इट्स अ डिस्प्लेसमेंट फ्रॉम द मीन पोजीशन. y वैल्यू को कैलकुलेट करना है. मिडवे मीन पोजीशन ऑफ द टर्मिनल पोजीशन. नो 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 नो. इसका आंसर होता है यार. Actually everyone will be think like that only. If potential energy increases, kinetic energy decreases, means midway of anywhere these two will be equal. Like this way you will be thought, but it is exactly wrong. क्या है ना? देखो इधर kinetic energy के लिए equation है. What is that? Of m, sorry, we'll write directly in terms of position. Just a minute. ओके. पोटेंशियल एनर्जी के लिए हाफ के ये स्क्वायर है. पोटेंशियल काइनेटिक एनर्जी के लिए हाफ के ये स्क्वायर माइनस वाई स्क्वायर है. करेक्ट ना? काइंडली चेक दिस इक्वेशन वंस. राइट? इन टर्म्स ऑफ पोजीशन, के हाफ के बोथ द साइड कैंसल. रिमेनिंग थिंग विल बी ये स्क्वायर माइनस वाई स्क्वायर इज इक्वल टू ये स्क्वायर होता है. करेक्ट ना? एंड देन इफ यू टेक वाई स्क्वायर टू लेफ्ट हैंड साइड, देखो इधर वाई स्क्वायर माइनस ए स्क्वायर माइनस वाई स्क्वायर. ये थोड़ा कंफ्यूजन हो गया, उल्टा लिख दो. वाई स्क्वायर माइनस ये स्क्वायर है इक्वेशन. राइट? दिस इक्वेशन को रीअरेंज कर लो यार. बाय मिस्टेक आई रिटर्न दिस वन. दिस इज, आई विल राइट अगेन. Pardon. Okay, here y square minus a square. Correct now? Okay, next y square minus a square is equal to a square. We need to calculate the value of y. Take a square to right hand side. then it will become y square is equal to a square plus a square. Y square is equal to 2 times the a square, right? देखो एक बार, then y value will be equal to under root something, what mistake it is coming, where I missed it. Guys, check it once. Kinetic energy के लिए equation क्या है? Is it right or wrong? Just give me a second. I will recorrect this one. Yes, of course. Just a minute. Where kinetic energy is equal to potential energy, no? Just a minute, just a minute. Here it is. By mistake, I written that one. Yes, yeah. Yes, yes. I did one small mistake here. क्या है ना? देखो इधर, सुनो 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 सुनो, इधर काइनेटिक एनर्जी के लिए इक्वेशन होता है ऑफ के ए स्क्वायर माइनस वाई स्क्वायर. ओके, पोटेंशियल एनर्जी के लिए क्या इक्वेशन होता है? ऑफ के वाई स्क्वायर होता है, राइट? देन रिमेनिंग क्या है इधर? काइनेटिक एनर्जी. ओके, नो प्रॉब्लम. बोथ द साइड दिस टू आर कैंसल होता है. देन a square minus y square is equal to y square, same only coming, no? Again, yeah, this time look at here. A square is equal to y will become to right hand side, means y square plus y square. It will be 2 times the y square. The left hand side mein a square. We need to calculate the value of y. Take 2 to left hand side, then it will become a square by 2 is equal to y square, right? Now squaring on both sides. When you do squaring on both sides, a square will become a, 2 will become under root 2, y will be become, y square will become y. Meanwhile, guys, this is the position. This is the position. At this position, the kinetic energy will be equal to potential energy. What is that position? A by under root 2. At this position, kinetic energy of the whole system will be equal to potential energy. Clear? Is it clear, right? Hope it is clear. Text me in the chat box, guys. Is it clear, right? At least do text me. Not at exactly midpoint, actually at a by root 2 position में क्या होता है? काइनेटिक एनर्जी पोटेंशियल एनर्जी के लिए इक्वल होता है. क्लियर है ना? ओके, वेल, विल मूव टुवर्ड्स नेक्स्ट क्वेश्चन, नेक्स्ट कॉन्सेप्ट. नेक्स्ट कॉन्सेप्ट है आज का वेव. एक्चुअली वेव क्या है? वेव, when I ask this question to all of you, means you will simply say like this, sir wave होता है ना sir, ऐसा, this is wave, correct na? Yes, of course this is a wave, but where we can see this one, how to analyze this a physical quantity, and what are the characteristics of this wave, everything we need to look into it here. Okay, we'll go one by one. Okay, basically where we can see the waves, मान लो, think it, actually you people are standing beside the bank of a क्या है, रिवर है ना? नहीं है. ओके, एक पॉन्ड है. ये क्या है? दिस इज अ पॉन्ड. दिस इज समर सीजन. योर वेकेशंस आर सो कमिंग वेरी नियर, correct na? I think you are planning to go home. When you go home, definitely you are going to visit your village pond, correct? Actually pond will be very cool, calm, and you people are standing near the bank of the pond. Think like this. Okay, you are actually nearby the pond. When you standing nearby the pond, आपका एक जन्म सिद्ध हक होता है. क्या होता है? जन्म सिद्ध हक। ओके, इट्स योर वन प्रॉपर्टी होता है। क्या होता है? ये पॉन्ड के अंदर एक पत्थर डालना है, करेक्ट ना? यू नीड टू थ्रो ए स्टोन इनसाइड द यस, इनसाइड द पॉन्ड। यस, ओके गाइस, देखो, एक्चुअली यू आर स्टैंडिंग beside a pond. Okay, when you are standing in front of beside a pond, आपका एक जन्म सिद्ध हक होता है क्या करना? उसके अंदर एक पत्थर मारना, पत्थर को फेंकना होता है, करेक्ट ना? यू नीड टू थ्रो ए स्टोन इनसाइड द पॉन्ड, दैट इज योर जन्म सिद्ध हक, करेक्ट ना? आफ्टर देन व्हाट यू विल गोइंग टू observe there? What you will observe there? Like this structure you will observe, no? Guys, those who are on turn on your camera, please shut off your cameras. Okay, right now, after throwing a stone inside the water, you maybe observe like this pattern on the surface of the water, right? This is a pattern you may observe on the surface of the water, correct now? If you throw a stone here, means there will be up and down, up and down, up and down, up and down. क्या होता है? एक pattern create होता है, right? These are the patterns which are created over the surface of the water. Actually, this is we called wave. ये क्या है? Wave है। Complete. Wave is a simple, guys. Actually, water, ये water है ना? Actually, water is a medium. क्या है? Water, it's an medium. Previously, before throwing a stone inside the water, it is very calm, cool, correct now? When you throw a stone inside the water, this medium get disturbed, correct now? This medium get disturbed, right? After disturbance, there is a pattern which is creating over the surface of the water. We call this one as an wave. Clear है ना? Wave का definition आ गया ना? वेव क्या होता है? सिंपल, इट इज ए डिस्टर्बेंस, it is a disturbance created over the medium, right? Disturbance created over the medium is called wave. Clear? Wave का मतलब finish, no? Right? In our daily life, we are seeing these waves in so many aspects. For example, I told you now, on the surface of water, the pattern which is created, it's a wave. And when you turn on the bulb in your home, bulb को turn on करते हैं आप, क्या? Bulb. Okay, light will be come out, right? Light will be come out. This is also light coming out from the source in the form of wave, right? And then here I'm talking, correct now? This is also energy which is carrying in the form of wave, means sound waves also a wave pattern होता है. Clear? Hope it is clear. Okay, fine. We'll move to the next point. Yes, देखो इधर wave क्या होता है? Wave, it's a kind of disturbance which is produced in a medium, right? Clear है ना? Wave को कैसे represent करते हैं? ऐसे represent करते हैं wave को. Okay, here is a physical representation of wave. It's an sinusoidally varying values. Clear है ना? This is wave basically. In this wave, this topmost we called crest and bottommost highest point we called trough. Clear? These are the 2 points which you need to note down. I will explain once again, no worries. Wave क्या होता है? देखो, wave means it's a kind of disturbance produced in a medium. Clear है ना? And moreover guys, देखो इधर, देखो देखो, this is a pond. Inside the pond wave is created, correct now? When wave created, no, here pattern will be formed, right? Here down up down like this, right? When it is pattern created, this is the higher potential energy term, high potential energy. This is low potential energy. Due to this high and low potential energy, क्या होता है, energy will be carry होता है, energy will be carried in this direction. Okay, and one more point, when disturbance created, energy is carrying in this direction, means particle, this is a क्या है, a particle होता है ना उस position में, it will not move, particle will not move, only it will be vibrate up and down only, particle will vibrate up and down only. How in center high potential will be there? In center, how high potential is not there, bro? Okay, in center high potential is not there. Characteristics of wave a concept hai. At that point I will tell you how the potential will be, potential difference will be takes place in a wave. Okay, due to this potential difference, energy will be, how it will be carried in a forward direction, I will tell you. Cool. Okay, next point, classification of wave. Guys, actually majorly waves go, we are going to divide into two categories majorly. First one is mechanical wave, second one is non-mechanical wave. Mechanical wave क्या होता है, mechanical waves को ट्रांसमिट होने के लिए, मीन्स प्रोपोगेट होने के लिए एक मीडियम का जरूरत पड़ता है. A medium is required to propagate or carry the energy. A medium is required, that is known as the mechanical waves. For example, मान लो this is me, I'm talking inside a room, किधर, क्लासरूम में बात कर रहा हूं मैं. Okay, when I'm talking, this sound is a sound, no, this sound should be reach everyone, means inside air molecule should be present. This is a medium, air molecules is the medium, should be present. When air molecules will be there, then only the energy which I'm talking, it will be reaches the another person here. Clear? Or else the energy will not carried out here. Here sound is a form of energy, it will be transmit over when there is a particle medium is present, air medium, or else it won't travel. For example, देखो इधर sun है ना, sun है, actually sun is we called, it's a burning star, sun is an burning star, correct now? I think you might be observed a few things when you're going to put some fire to the wood. Okay, you just listen, when the woods are starting to burn, it will give the sound, right? Woods will give the sound. That is what the topic, no, I will explain. That is what the topic I will explain. Listen. Okay, here देखो, sun is an burning star, I told, no, when it is okay, what I'm telling, yeah, when you put the fire to the wood, actually wood will be start to burn. When it is burning, sound also will be appear from that burning wood, correct now? You might be heard that sound, right? In a similar way, sun, देखो sun कितना बड़ा star है, right? It is also burning. Why we can't able to hear the sound of the burning sun? Can you give me the reason why we are not able to, means unable to hear the sound of the burning sun? Why? देखो आपको ये इधर ही आंसर मिलता है, बिकॉज गाइस देखो, हाँ, I got, that's it. That's it. देखो, from the sun to earth atmosphere, up to this point there is no atmosphere. Atmosphere नहीं है, इसलिए sound will not reach the earth. That's it. एनर्जी कैरी होने के लिए, फिर फिजिकल क्वांटिटी के लिए मीडियम का जरूरत पड़ता है, राइट? इफ देयर इज नो मीडियम देन इट वोंट ट्रैवल. क्लियर? दैट इज व्हाट द मैकेनिकल वेव. मीडियम का जरूरत है इधर. Coming to the next one, non-mechanical wave. It's very simple. Non-mechanical wave means here it do not require material medium. Without material medium also it will be travel. For example, first point in your CBSE textbook they written electromagnetic wave. What is that electromagnetic wave? It is nothing but this light wave. Light waves are the electromagnetic waves. करेक्ट ना? देखो इधर सन से अर्थ तक लाइट विल बी कमिंग मींस जस्ट बिकॉज ऑफ द वेव्स, द रेडिएशंस व्हिच आर कमिंग फ्रॉम देयर, दे डू नॉट रिक्वायर एनी मीडियम. विदाउट मीडियम आल्सो दे विल कम. दैट्स व्हाई दिस लाइट रेज वी कॉल्ड एज एन नॉन मैकेनिकल वेव्स. along with that one, heat also coming, right? Heat energy also coming. Heat energy, that is also energy, that is also do not require any medium, right? Heat also do not require any medium to propagate. Clear है ना? ये दोनों mechanical and as well as non mechanical wave था. Hope it is clear. Coming to the next one, those are the two classification. And then coming to the next one here, based on the vibration of a molecule, based on the vibration of a molecule, we are going to further dividing the waves into two categories. First one is transverse wave, second one is longitudinal wave. ट्रांसवर्स की वेव क्या होता है? देखो इधर एक पार्टिकल है, ओके. ऑन दिस पार्टिकल यू आर गोइंग टू अप्लाई द फोर्स, राइट? ड्यू टू दिस फोर्स क्या होता है? पार्टिकल विल वाइब्रेट फ्रॉम द मीन पोजीशन अप एंड डाउन. अपसाइड एंड डाउन साइड वाइब्रेट होता है. And the neighboring particle when it is vibrate due to the potential difference, again the neighboring particle क्या होता है? When it is going up, the neighboring particle will be in the same position. When it is coming down, at that point neighboring particle will start to move up. Both दोनों same phase में नहीं होता है. I will tell you that one later. Okay. And then in a similar way, vibration will be takes place up and down in a whole medium for all the particles. Correct now? Like this vibration will be takes place in a up and down vertical path में, but the energy will be carried in this direction. देखो इधर एनर्जी कैरी होने के लिए डायरेक्शन है ना, उसको परपेंडिकुलर डायरेक्शन में क्या हो रहा है? पार्टिकल वाइब्रेट हो रहा है, राइट? वाइब्रेट हो रहा है. लाइक दिस wave को we call transverse wave. Transverse wave are very simple guys. The vibration of a particle is perpendicular to the propagation of energy direction. That's it. Like this waves we call transverse wave. Clear? Clear ना? बोल दो एक बार चैट बॉक्स में ट्रांसवर्स वेव क्या होता है. देखो इधर definition भी है. Particles vibrate perpendicular to the direction of propagation of wave. These waves we called as an transverse wave. Clear? Hope it is clear. इधर से इधर तक रिलेट करना है इसको. क्लियर ना? एग्जाम्पल क्या होता है ट्रांसवर्स वेव को? बोल दो ना चैट बॉक्स में. नाउ यू टेल मी. Actually, you studied this one in a 9th standard, I think, 9th or 8th standard. ट्रांसवर्स वेव क्या होता है? एग्जांपल्स क्या होता है ट्रांसवर्स वेव के लिए? आपको वायलिन पता है ना? violin, tabla, tabla. These are violin. So the tabla है ना, a stretched membrane है. When you're going to put the force on the stretched membrane, the membrane will start to vibrate in up and down position. Correct na? Due to the up and down position, energy will be carried out. Correct na? That's why from this instrument the sound will be coming. That is an example for the transverse wave. And then in कहा देखते हैं आप, सितार. सितार में क्या होता है, एक स्ट्रिंग होता है. स्ट्रिंग्स को क्या करना है, शेक करना है. स्ट्रिंग को, स्ट्रिंग होता है ना, स्ट्रिंग को क्या करना है, शेक करना है, मीन्स ऑसिलेट करना है. when it is start to oscillate, that time also the sound will be coming. That is an example for transverse wave. Clear है ना, transverse wave. Okay, coming to the next one. Next one क्या है, next one, yes, that is longitudinal wave. A longitudinal wave क्या होता है, actually I told you that, देखो इधर in the left side corner में, this is a particle. Due to the here the particle vibration will be like this, to and fro motion. आगे जाता है, पीछे होता है. When it is move forward direction, it will, what are the energy which is carrying by this particle? No, it will be transferred to the neither atom, neighboring atom. This atom again start to move in forward direction. It will forward the energy to the neighboring atom, and again it will be come back to the original place. And again the neighboring atom which is receiving the energy previously, okay, what it will do, it will pass the energy to the another neighboring atom, and it will be returning to the original position. Means here vibration of particle क्या हो रहा है, along the direction of propagation of energy हो रहा है. Energy in which direction it is propagating? No, in the same direction vibration of particle हो रहा है. सिंपल है यार. मान लो इधर 10 मेंबर्स है, 10 स्टूडेंट्स है, 1 2 3 4 5 6 7 8 9 10 इधर तक. एक्चुअली क्या बोला मैंने, इधर अब मैंने खड़ा होता, ओके, इन फर्स्ट पॉइंट, फर्स्ट पर्सन को क्या बोला मैंने, एक चॉकलेट दिया, बोल दिया दिस, मान लो दिस चॉकलेट इज एन एनर्जी. ओके, मैंने बोल दिया इसका कान में, ये चॉकलेट को, एनर्जी को पास करो. This person will pass this energy to this one. After then it will be, he will be returned to its original position. The second person who is getting the energy, he will pass the chocolate to the third person. He will return to its original position. And similarly, this vibration means carrying of energy will be takes place till the end of the person, till the end of the 10th person. Means whole medium the vibration will be takes place in a similar way. Here देखो इधर vibration in which direction it is happening, go in same direction energy is carrying, right? Like this wave we call longitudinal wave. देखो इधर longitudinal wave, करेक्ट ना. longitudinal wave को एग्जांपल इधर है, देखो ये होता है like this compression part है, this is the rarefaction part है. Means in few, if you're going to, when I'm talking inside the room means the air molecules will be compressed होता है. compress होने के बाद energy neighboring set of molecules को transfer करता है. after then refaction होता है like this. after then giving the energy to the neighboring, again compression, refaction, compression, refaction. We call this one as Licloisco. This is very important, guys. This portion we call compression. Compression. This portion we call refaction. Refaction. FACTION. Refaction. Okay. Longitudinal waves carry the energy in terms of guys compression and rarefaction, but transverse waves carries the energy in terms of crest and trough. क्रेस्ट एंड ट्रफ पोर्शन में एनर्जी को कैरी करता है। कौन कौन ट्रांसवर्स वेव। क्लियर, होप इट इज क्लियर, होप इट इज क्लियर। थोड़ा बहुत ज्यादा कहानी है, मैथमेटिकल एक्सप्रेशंस नहीं है थोड़ा एडजस्ट कर लो। ओके, नेक्स्ट वन, कैरेक्टरिस्टिक्स ऑफ वेव। इसमें क्या कुछ नया कुछ नहीं है। वेवलेंथ क्या होता है, देखो इधर, दिस इज द वेव मान लो, ओके, इट इज वेरिंग sinusoidally. This is a peak point crest, this is a peak point in a downward direction we call trough, and again this is a peak point crest, and this is a peak point in a downward direction trough. Correct now? Here from any one point like how can I say, crest to crest ले लो, or else trough to trough ले लो, whatever the total distance is there, no, we call this one as an wavelength. Crest to crest or else trough to trough distance we call the wavelength. Clear? Wave का length है। ओके, देन वेवलेंथ हो गया। वेवलेंथ इज नथिंग बट, लिख लो, डिस्टेंस बिटवीन क्रेस्ट टू क्रेस्ट और ट्रफ टू ट्रफ। क्लियर है ना? दैट्स इट, दैट्स इट। एंड मोर ओवर, देखो इधर, सुनो 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 सुन। ओके, इधर फ्रॉम 0 टू हियर टू, ये लोग ब्लू कलर दिख रहा है ना, 0 टू अप टू दिस पॉइंट, इट विल मेक वन कंप्लीट साइकिल। करेक्ट ना? दिस इज वन कंप्लीट साइकिल। देखो, आई एम ट्रेसिंग द वेव, नो, दिस इज वन कंप्लीट साइकिल। ब्लू कलर वाला वन कंप्लीट साइकिल। ये वन कंप्लीट साइकिल करने के लिए वेव कितना टाइम लेता है, वेव कितना टाइम लेता है, इसको हम कहते हैं टाइम पीरियड। टाइम पीरियड मीन्स टाइम टेकन by the wave to complete one cycle, to complete one cycle. Correct na? In case yesterday class I told that, okay, yesterday class mein, yesterday means day before the yesterday I told you that in a similar way in 1 second mein wave will complete around 4 to 5 cycles. Then number of cycles made in 1 second, we call that one as an frequency. Time period को हम second में SI unit लिखते हैं, frequency को second inverse or else hertz. Hertz is the SI unit for frequency. Clear ना? Clear? Hope it is clear. And then coming to the next one, relation between frequency and time period. एक क्या relation है frequency and time period में? देखो, frequency and time period में एक relation होता है. Frequency is actually inversely proportional to the time period. Okay, this is the relation between frequency and time period. Clear? Clear, clear. Okay, we'll move to the next slide. Next, relation between frequency and velocity and wavelength. ये बहुत interesting है, and also guys, believe me, this is the very important equation for your chapter. Waves में बहुत important chapter start हो रहा है, means equation from this equation only. Correct ना? Here they given velocity, wavelength, frequency. Velocity means wave velocity होता है। क्या होता है? Wave velocity. लिख दो इधर, wave velocity. Wave velocity. Velocity, how you going to define actually? Displacement by time taken. लिख दो इधर same way. Displacement बाय टाइम टेकन, करेक्ट ना। डिस्प्लेसमेंट क्या हो रहा है बाय, इधर मैक्सिमम डिस्प्लेसमेंट मींस वेव का वेवलेंथ ही होता है, लिख दो इधर डिस्प्लेसमेंट लैम्डा, टाइम कितना होता है, टाइम पीरियड, दैट्स इट। वेव वेलोसिटी के लिए v से रिप्रेजेंट करो इसको, v से रिप्रेजेंट करो, देन क्या होता है इक्वेशन देखो, v इज इक्वल टू लैम्डा इंटू टी, राइट। we got one equation guys, v is equal to lambda into t, but वेलोसिटी हो गया, टाइम पीरियड हो गया, वेलोसिटी हो गया, वेवलेंथ भी मिल गया, देखो वेलोसिटी हो गया, वेवलेंथ भी मिल गया, और एक है फ्रीक्वेंसी। फ्रीक्वेंसी कहाँ से मिलता है यार, एक्चुअली नो ओनली आई टोल्ड फ्रीक्वेंसी इज नथिंग बट 1 बाय टाइम पीरियड, करेक्ट, 1 बाय टाइम पीरियड। इधर देखो 1 इधर है, टाइम पीरियड इधर है, ए इक्वेशन पे 1 बाय टाइम पीरियड फ्रीक्वेंसी लिख सकते हैं ना मैंने, देन इट विल बी बिकम, देखो क्या होता है, v is equal to lambda 1 by t को फ्रीक्वेंसी न्यू, ओके आई विल राइट फ्रीक्वेंसी को न्यू, ये रेफ लिख दिया था मैंने, सॉरी, फ्रीक्वेंसी मींस न्यू, न्यू, न्यू स्टैंड्स फॉर गाइस फ्रीक्वेंसी, क्लियर है ना। देन वी गॉट ऑन रिलेशन फॉर दी फ्रीक्वेंसी वेलोसिटी एंड लैम्डा, क्या है, वेलोसिटी इज इक्वल टू न्यू लैम्डा, लिख दो, ये वेरी इंपॉर्टेंट इक्वेशन है गाइस, ओके। वेलोसिटी विल बी इक्वल टू न्यू लैम्डा, वेलोसिटी इज इक्वल टू न्यू लैम्डा, v stands for wave velocity, wave velocity, nu stands for frequency, lambda stands for wave length, wave length, क्लियर है ना, is it clear, okay, that's great, we'll move to the next point। हाँ, नेक्स्ट कॉन्सेप्ट है रिलेशन बिटवीन पाथ डिफरेंस एंड फेज डिफरेंस। गाइस whenever they will ask no relation between path difference and as well as phase difference, simple है, when we need to find out the differences means we need to take two particles, okay, with one particle wave we can't able to define this one, मान लो this is the first wave, okay, this is the first wave, रेड कलर है हो रहा है ना इसके ऊपर, this is the first wave, here it is making an angle theta, yesterday only I told theta is nothing but phase, phase होता है, करेक्ट ना। नाउ मान लो और एक पार्टिकल है नाइबरिंग पार्टिकल, I told that with the same phase it will not vibrate, when energy will be carried, no, देखो इधर this particle is vibrating upward direction means this particle will not vibrate in upward direction, okay, it will be vibrate in downward direction, it will be vibrate in downward direction, meanwhile neighboring, लिख दो इसको, neighboring particle never be vibrate in same direction, in a same direction neighboring particle at a time, at a time they will never vibrate, one particle will go upside means when it is moving downward direction then only this particle will be, this particle is coming down means this particle will start to move up, right, like that, करेक्ट ना। मे बी अनदर पार्टिकल, देखो इधर फर्स्ट वेव हो गया, सेकेंड वेव मे बी इट इज मूविंग फ्रॉम दिस पॉइंट एंड लाइक दिस, थोड़ा गलत हो गया तो कोई प्रॉब्लम नहीं, देखो इसका फेस तो इधर है, इसका फेस तो इधर है, थीटा 1 दिस इज थीटा 2, करेक्ट ना, ये फेस क्या हो गया, डिफरेंस हो गया, यस आई विल एक्सप्लेन, I will explain, सुन 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 सुन, this is a particle, Actually, it is vibrating upward direction, downward direction. Due to this vibration, the wave will become like this. Correct now? This is the wave which is created due to the vibration of particle. The particle, this is the A. When it is vibrate, the neighboring particle which is present just beside of it, it will not vibrate simultaneously. This particle will not, when it is moving upward direction, this particle will also not move upward direction. Okay, either it will be at rest. When this will be disturbed, क्या है ना, सिंपल है भाई, सिंपल है. सुनो सुनो बोलता हूँ. दिस अ पार्टिकल, और मान लो दिस इज यू. आई एम गिविंग सम अमाउंट ऑफ एनर्जी टू यू. व्हेन आई गिव द एनर्जी, you started to move upside because you got the energy, right? You are disturbed, that's why you created a wave here. When you go upside, the neighboring particle, it is not yet get any energy. When it is coming down, when you coming down, at that moment you are creating the disturbance for the next molecule. At that time, this second, this is ये u d है ना, इसको एनर्जी मिलता है when you coming downward direction. At the moment it start to move upward direction. When it is start to move upward direction, you will be go downward पूरा, because इसका पोटेंशियल एनर्जी ज्यादा होता है. दैट टाइम यू विल बी, पोटेंशियल एनर्जी बहुत कम होता है तो हम आपके साथ. अगेन नाइबरिंग पार्टिकल को नहीं मिलता है एनर्जी. when it is coming down, the neighboring particle will be start to move upside. That's why I told you that when particles are vibrating, all the particle will not have a same pace. Same pace नहीं होता है. But their amplitude means particle A receives the energy, it will be jumps to this much height, and the particle, when it is giving the energy to the particle B, when particle B receives the energy, it will also rises the same amplitude. Height को same amplitude rise होता है. Third particle also will have the same energy. Energy will be same होता है, but phase will not same. Only the thing is amplitude is same. Amplitude is same. Clear now? Hope it is clear. Okay, similar way, this is the theta 1. मान लो second wave will be start in opposite direction, means this is theta 2. ये दोनों का बीच में phase difference हो गया. Correct? Or else मान लो first one will be start from this point, second one will be started from this point, means again phase difference हो गया. देखो इसका फर्स्ट वाल का phase difference theta 1 था, इसका theta 2 था. Correct ना? And then here from point origin to here distance will be x हो गया, means path will be not same. इसको भी एग्जांपल देता हूं मैंने. सुनो सुनो सुनो. दो बहुत अच्छे फ्रेंड है, दो बहुत अच्छे फ्रेंड है. फ्रेंड ये is starting from point A and he is walking in this direction. Okay, and friend B is starting from point B. At this point से start करता है. ये दोनों को बीच में डिस्टेंस होता है ना x, some path difference है. इसको हम कहते हैं path difference in terms of wave. Phase difference क्या है? Phase difference is the angle. Path difference means where they will be start. Here first wave will be starting from, इसको नहीं मानना है. First wave will be start from 0, second wave will be start from here pi. करेक्ट ना? कंप्लीट वेव का एंगल होता है 2 पाई. सेकेंड वेव किधर से स्टार्ट कर रहा है? पाई से स्टार्ट कर रहा है, मींस पाथ डिफरेंस हो गया इधर. फेज डिफरेंस एंड पाथ डिफरेंस को फाइंड आउट करने के लिए ये इक्वेशन यूज करते हैं. क्या है वो? डेल्टा फाई इज इक्वल टू 2 पाई बाय लैम्डा इंटू डेल्टा एक्स. दिस इज वन ऑफ द इक्वेशन विच वी आर यूजिंग टू फाइंड आउट द पाथ डिफरेंस एंड एज वेल एज फेज डिफरेंस. Okay, clear है ना? We'll move further. Okay. Next one, characteristics of progressive wave. Progressive wave का characteristics क्या है? First one, wave profile move. क्या होता है ये wave profile move? Simple है. When you're going to disturb the medium, when you're going to disturb the medium, wave will be propagate होता है. Means wave start to move in one direction. Wave move होता है in unidirection. In one direction, it will start to move in a single direction with SHM. Simple harmonic motion करता है कौन? Molecules. And then this is actually a sinusoidally varying wave. Sinusoidal varying wave. Correct now? Sinusoidally means graphically as shown. No, this is actually sinusoidally varying wave. Okay, एक पॉइंट हो गया. दूसरा पॉइंट क्या है? दूसरा पॉइंट है ये, all the particles vibrate with the same amplitude. Guys, it is very simple. हाँ, मैं कुछ गलत लिखा है क्या? करेक्ट है ना? साइनोसॉइडल. साइनोसॉइडल मीन्स एक्चुअली ट्रिग्नोमेट्रिक फंक्शन साइन पता है ना भाई? हाँ, उसके वजह से वेरी होता है. आई विल टेल यू. लिसन लिसन लिसन. Actually, in oscillation only I told this one. Y is equal to A sin omega t. Omega t is nothing but theta बोल दिया मैंने. Okay, if you put the value of theta is equal to 0, displacement किधर होता है? theta. Sin theta, sin 0, 0 होता है ना? 0 means displacement. Y value will be here. Correct ना? If you put the theta value 90 degree, sin 90 will be maximum. Sin 90 means 1 होता है, that is equal to A when it will be comes to here. And again theta value will be 180 at the time. Sin 180 again 0, it will comes to this point. And again theta value you will put the 270, and again it will becomes to maximum -1 here. Again theta value will be 360 degree, and again it will comes to mean position. When you're going to join this one, no, it will comes like this. This is actually wave which is actually varying according to the sine function. According to the sine function. That's why we call this one as an sinusoidal wave. Sinusoidal wave. Clear? Clear ना? क्वेश्चन पूछते हैं यार, आफ्टर क्लियरिंग नहीं बोलते आप लोग. थैंक यू बलारी. ओके, नेक्स्ट वन. एम्पलीट्यूड सेम होता है. देखो इसका एम्पलीट्यूड कितना होता है ना, उतना एम्पलीट्यूड ये वेव का भी होता है. सेम एम्पलीट्यूड बनाता है. नेक्स्ट वन, नाइबरिंग पार्टिकल वाइब्रेट विद अ डिफरेंट फेज. आई टोल्ड यू दैट दिस इज द फर्स्ट पार्टिकल वाइब्रेट हियर अपसाइड डायरेक्शन मींस सेकेंड पार्टिकल को एनर्जी नहीं मिलता है इन अ सेम टाइम. इन अ सेम टाइम सेकेंड पार्टिकल को एनर्जी नहीं मिलता है, इसलिए this is the energy upside means it won't vibrate. When it is coming down, it start to vibrate after receiving the energy. That's why they are not in a same phase. Different phase hota hai. All the particles will be vibrate. Its medium है means in a medium all the particle will be vibrate due to receiving of energy, and then produced by disturbance in a medium. Yes, of course, the particles which are vibrating means that is just because of the disturbance which is produced in the medium. बोल दिया था मैंने इनिशियल क्लास में, ये पानी है मीन्स पानी के ऊपर पत्थर डालने से क्या होता है, on the surface of a water there is a wave will be created like this. This is what the disturbance which is created by the stone. Correct now? That's it. And then transmits the energy. Of course, when wave will be started, due to the potential difference, the energy will be carried over the medium. These are the characteristics of progressive wave. Progressive wave का मतलब है, progressive means moving. Moving wave का characteristics क्या है बोल दिया था. Wave which is moving in a unidirection. Second one, all the particles which are moving in a, how energy will be transmitted. बोल दिया ना भाई, अभी अभी बोल दिया मैंने. क्या होता है, मान लो, मान लो these are all the particles in a medium. These are all the particles in a medium. आपको पता है guys, basically this is a mass object m. On this mass object, if you're going to put some amount of force, means mass object will be moved some distance, displacement. Correct ना? We say this one as an work is done. Work done को कैसे calculate करते रहे? F into S. Means work done here, it is nothing but energy. When this energy will be done, when the energy has been done to the applied force, object should be displaced. Correct now? That time we said that work is done, and again this work done is nothing but, I told you that, energy. Work done is nothing but energy. Similar way, this is medium. This is medium. Medium contains n number of particles. N number of particles को क्या कर दिया है, जोड़ दिया है. If I am going to apply some amount of force in terms of sound, correct ना? क्या होता है, a sound actually disturbed this first molecule. When it is disturbed, this molecule will start to vibrate. When it is start to vibrate, this molecule will come and hit this energy, hit this second particle. First particle क्या होता है, second particle को hit करता है. Correct ना? When it is hitting, at the moment it's an elastic collision, exactly elastic collision. Momentum, kinetic energy, both are conserved here. Okay, don't think like that it's a brittle one. It's an completely elastic. It completely transfers the energy. Whichever the energy which is received by the first particle, it transmits to second one. Second particle क्या होता है? The particle which second one which receives the energy, no, that energy will be transmitted to this third one. Third one will be fourth one को transmit करता है. Fourth one, fifth one को, fifth one, sixth one को. Like this, the energy will be throughout. It will be transferred. Work done हो रहा है by इधर molecule से. Work done हो रहा है. This work done is stored as an energy. The energy which is received, that energy only it will be give here. Clear है ना? Now tell me. Tell me. Yes. Yes, that's great. That's great. Okay guys, all the times okay. कितना था? Last एक इक्वेशन करना था. कोई प्रॉब्लम नहीं. Tomorrow will talk about the progressive wave. एक इक्वेशन बनता है. वो 4 types का progressive equation will write. Okay. Based on that, we'll solve good 2 numericals. After then, few things are there which are very important for your examination. We'll discuss that one now tomorrow class. Okay. आज का बता दो, कमेंट करो चैट बॉक्स में. ओके, कोई बात नहीं. Okay, we'll see you in our tomorrow class. Until then, take care.